All right, on this lesson, I'm going to have to do it differently than what they did because factoring trinomials is actually a big topic, and there are easier problems that we're going to start off this morning doing, and then there are going to be more difficult problems which we'll do, I believe, this afternoon, depending on how much we can get through today. Okay, let me give you a multiplication problem here. Let's go with x plus 3 times x plus 8. Go ahead and work that one out. Get me my product of these two binomials. So multiply these out and make sure your answer is in simplified form. So x plus 3 times x plus 8. Okay, did you guys get your x squared plus 11x plus 24? Okay, that was what you did in chapter 9. You multiplied two binomials and you got a trinomial. Today, it's called factoring trinomials. What does it mean to factor? Do you guys remember it? Yeah, what's factoring?
What is the GCF?
Okay, part of it is finding a GCF, but the word factor means to write that expression as a what type of problem? Multiplication problem. So we're going to go from this trinomial into these binomials today. But can you guys understand, is this a multiplication problem right here? Right here. Is that a multiplication problem? Is this a multiplication problem? Okay. What kind of polynomial is over here as your answer? What do you call that? What kind of polynomial? Trinomial, because it has how many terms? 3. Okay, if you were able to go from here to here, you can do half of your problem on this next lesson. The other half is going to be a little bit of guesswork, okay? So if you're good with this, we're going to move on to another example. Go to page 578, and what we're going to be doing is we're going to be taking a trinomial and then finding out its binomial factors. Okay, so write this problem down. It may look familiar. T squared plus 7t, and it's number 11 I'm doing. Or excuse me, number 13 that I'm doing. T squared plus 7t plus 12. Seven. Okay. Let me ask this question. Is this a multiplication problem? No, it's an addition problem. If I'm trying to factor it, what do I have to rewrite it as? A multiplication problem. Okay, what kind of polynomial is this? Trinomial. It's going to factor automatically. I know it has to factor into two binomials. It's got to be two binomials. I'm going to have a binomial here and a binomial here. So 2 terms each. Does anyone know what should go in the first spot of each binomial? Automatically, you should know this, I hope. Lucy? T. T goes right here. Do you guys remember FOIL? What's T times T? T squared. So that works. That'll work for that first one. The whole point of this lesson, really, for this morning, is to find out what goes in the second spot. And have you guys ever heard of a problem-solving strategy called guess and check? Oh, my. Guess and check. Oh. I want somebody to guess what should fit in these two spots. Anyone? And don't be afraid. The last class, they guessed, and it was way off. And that's okay. But hopefully you don't have the right answer, because we want to kind of practice this here. Yeah, Jack?
3 and 4.
3 and 4. Why'd you pick 3 and 4?
Because 3 times 4 is 12.
Is that what you're going to say, Autumn?
3 plus 4.
So positive 3 and positive 4. Let's see. That sounds really nice, but I don't know if that even works. Do you guys know how you can check this? FOIL. So what's t times t, everyone? T squared. What's t times 4? 4t. Yes, thank you. What's 3 times t? 3t. What's 3 times 4? 12. What are these two combined? Whoa. This is like we guessed on the first try and we got it. Man, that's not supposed to work. That's nice if it does. Oh, man, Jenna, why'd you give us a shortcut already? Sorry? Yeah, let's be kind. So if I'm looking at this problem, I'm thinking to myself, I get it now. Yes, that works. But how in the world do you just pull out 4 and 3 and it works? I need us to look at these numbers and see relationships. Okay, you see the number 12? That's the constant. That's the number that has no variable next to it. Can you guys give me factor pairs of 12? Do you remember on the first lesson I said, list the factors of 12? What are factor pairs of 12? So what times what equals 12?
1 and 12.
1 and 12. 1 and 12. What else? 3 and 4. 2 and 6. Anything else? Yeah, 2 and 6 right there. Okay, so really what you're doing is you're looking at that constant, so 12. And then you're looking at the factor pairs and you're saying, which one of these work? So I'm going to pretend that you guys are not so bright. And we're going to guess. I'm going to pick 2 and 6. Okay, I'm going to put positive 2 and positive 6. By the way, it doesn't matter which one you put. Like if you put 2 here or 6 there, it doesn't work. It doesn't change it. I get t squared plus 2t plus 6t plus 12. Oh, I get the first one and the last one, but what about that middle one? I'm off by 1. So does 2 and 6 work in these spots? Nope. So now you would try the other two. Why would 1 and 12 not work? Raise your hand. Sorry, raise your hand. Just so we have one. Raise your hand. Anyone know why 1 and 12 will not work? Because it is a factor pair. What's 1 times 12? 12. What's 1 plus 12? 13. That doesn't give it to me. All right, let's go with this next problem here. See if we can get this pattern down. Number 6, x squared plus 4x minus 45. Number 6, x squared plus 4x minus 45. I was asked many times. I've been asked many times since we've gone over this in my years. Do the signs matter? What do you guys think? They matter. They matter a lot. I know it's going to be a binomial. Does anyone know what should go in the first spot? First spot on each one should be x. Boom and boom. Done with that. You're halfway done. Now I have to find out what numbers go in those spots. So I'm looking at this constant, and what's the sign of 45? Yes, it's a negative 45. I have to think of factor pairs of negative 45. So can someone give me a factor pair of negative 45? That may work, may not. Actually, give me the factors of 45. Anyone know? Just 45. 1 and 45.
3 and something.
3 and 15.
Yeah.
And then I heard 5 and 9. Okay. So doesn't one of these have to be negative in order to be a negative product? So you're going to have to pick which ones are negative. So which one do you think might work? Which pair?
5 and 9.
5 and 9? Okay. Which one should be negative? Which one should be positive?
9 should be positive.
Okay, let's do a vote since we're split. How many of you think 5 should be negative? Okay. How many of you think 9 should be negative? Okay. So I'm going to go with the majority, but then we'll check it. So 5 should be negative. 9 should be positive. Okay. What's negative 5 times 9? Negative 45. That works. What's negative 5 plus 9? 4. That also works. This is the answer. right here. If I put the signs reversed, like if I put positive 5 and negative 9, I would have gotten negative 45. But what's 5 plus negative 9? Negative 4, and that is not the same. Yes, sir?
I have a dumb question, but which one did you circle as your answer?
Both of them were. Like this whole thing. Because there are two binomials being multiplied. Yes?
So is this just like a guess and check?
It is a guess and check, but as you keep doing this guess and check method here, because really, here you have 3 chances or 3 guesses, but as you get better, you're going to really do it in one. Some of you are going to be able to do it just looking at it boom, boom, boom consistently. But sometimes you need a little bit of flexibility with guessing. So for now, have fun guessing and checking, and then after, you will do it consistently correct. Okay, you guys are doing too well on this, so I'm going to give you a tough one. Number 14. This is not that bad. But this afternoon, you will see that it gets a little bit tougher. C squared minus 13c plus 36. You know it's going to be 2 binomials, because a trinomial usually factors into 2 binomials. What's the first letter in each binomial? C. So, Mr. A, I have no clue what to do here. You at least know it's 2 binomials, and C goes in the first spot. So you basically know half the problem. The number part is going to take a little bit of time here. So what's the number I want to multiply to get? 36, positive, right? But I want them to add up to be negative 13. They both have to be negative. Because what's a negative times a negative? Positive. What's a negative plus a negative? So that's the only, so there got to be 2 negative numbers. Which 2 negative numbers? What a great question. Oh my, some of you already have it. What? I'm going to list some factor pairs. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. There you go.
4, 8, 9.
Negative 4, negative 9.
So negative 4, negative 9, I seem to have a strong pull toward. And they both have to be what?
Positive.
They both have to be what?
Negative.
Negative, yeah. And it doesn't matter. I'm going to put negative 9 here, negative 4 here. Okay, what's negative 9 times negative 4? Positive 36. What's negative 9 plus negative 4? There are no other numbers that can fit. That is my factoring of that trinomial.
There's more than one number.
There isn't more than one number, thankfully. There's only those 2 numbers, or this is the only answer. This is the only way you can write it for now.
But I mean, like, a different problem.
Yeah, what we're going to be doing this afternoon, I think you guys are ready for it, is you guys notice that c squared, what number is always in front of c squared? Like what's always being multiplied by c squared? 1. Look at your problems on page 579. Look at number 33. Does x squared only have 1 in front of it? No. There's a different process you go through. That's a little tougher. Yeah, you're going to start thinking a little bit more, and there's a process we'll go through, but that's this afternoon. Okay, how many of you kind of get this? You're kind of like, oh, that's not too bad. Raise your hand if you kind of get it. Okay, what I'm going to do is I'm going to give you 2 problems, and I want you to work in groups here. So here's how you're going to work, and it shouldn't take you that long. I'll have you three right here work together, you 3. You 3, Matt and Harrison and Lucy, you 2 back there, you 2, you 2, and you 2. I'm going to write these problems on the board. This is what I want. You're going to give me the factoring of the trinomials, and then I'm going to ask any one of you to give me the answer and tell me why that's your answer. So great, thank you for the answer. And you write it down. Why is that the answer? I don't know. I might just give you some more problems to think about it. Okay. So you can talk with your neighbor in your team, and here are the two problems. So we have a squared plus a minus 30. That's the first one. And then no numbers here. G squared minus 8g plus 16. All right, so go ahead and work on those together. Get me my two factorings here. And you're allowed to communicate, like one group is doing, two groups are doing,
Hey, what'd you get?
2.5 groups are doing. Sorry? You're with them.
Oh yeah, that is equal. So it's negative 5. Sorry.
I'm not sure if
Chair.
Sorry.
Oh.
Wait.
And if we call the method guess and check, you guess and then you can check. Like you can know if your answer is right or wrong. Like everyone who has an answer should be able to say yes, that's it, or no, that's not it. Like you can do it because you can just do FOIL and see if it works. If it doesn't work, it's wrong. If it does work, it is correct. It has to be correct. Okay, I'll give you about another minute, and you are allowed to communicate with each other about the problem with your group.
Make a positive, so if you do 2 components, it makes it right. So if you feel one person, if you feel another, you feel.
I think I have selected those who will explain to me what they're doing.
No, because
You can't multiply humans, you add them.
Yeah, 2 negatives make a positive. Yeah?
2 negatives in addition make a further negative. So
Oh.
it's going to be way worse if you kill 2 people than
Good
kill
point.
one person.
She's clarifying the operation. So like 2 negatives multiply together.
You can't multiply humans, so you can't make it a positive.
Stay here. Eat one.
Or you can just have it.
Yeah, or you could have babies. That's one way to clone, and all.
That's adding them.
But anyway,
You can just clip.
I'm glad you guys have a deep discussion there. Okay, on the first one, I want an answer from Brian. What'd you get for the factoring of a squared plus a minus 30? Oh, sorry, give me the complete answer.
A subtract 5 and
A plus 6? Okay, why'd you get those numbers? Or how did you get those numbers, I should say. So listen carefully because I'm going to ask you a similar question. Yep.
they're factors of 30. Or
Um,
and negative 3.
Good. So what's negative 5 times positive 6? Negative 30. And then what else? Because you have to have 2 parts that it fulfills. So that's 1.
6a subtract 5a is 1.
Yeah. Negative 5 plus 6 is positive 1. There's a 1 right here. So that works. Okay. He got away with it. let's go with. Sorry, my eyes are just moving around. Hi, Harrison. I see that hand. Give me the second one.
All right, so we got G minus 4.
G minus 4.
And G minus 4.
Wait, you said G minus 4. What's the other one? You said G minus 4 twice. Is that even possible?
No.
Okay, what's what's negative 4 times negative 4?
Positive 16.
Positive 16. What's negative 4 times negative 4, Harrison? Negative 4 plus negative 4?
Negative 4 times negative 4.
And then we gave the answer?
Negative 8.
Negative 8. There you go. So that's the only one that works. Let's see if you guys are observant here. We've already looked at problems like this in the last chapter, chapter 9. And you're like, can anyone tell me how to rewrite this problem here? Can I rewrite this here?
Yes.
G minus 4 squared. Isn't this a square of a difference? And do you remember that this is how you can write out that product? G squared, negative 4 times negative 4 is 16. And then 1G times negative 4 times 2, negative 8G. This is a special product, and that does occur on some of our answers. You don't have to know that per se, but it is actually very helpful to know. How many of you think you get this stuff? You're like, okay, it's not too bad. Okay, I want you to do this one alone. You will not have any help. You cannot ask me for help. And you will tell me if your answer is right or wrong. At the end, I'm going to say, check your work. And then you will be able to say, I got it right. I got it wrong. So, number 29. So you're working on your own. Please don't look at anyone's paper. Don't ask anyone for help. You will not get help. You will do this on your own. Number 29. All right, I'm coming by to check if you have your answer. Point to me. And I'm not saying it's right or wrong. I'm just looking at it. If I come by and you have it, yeah, point it out to me. Okay, and then I'm not going to check any others, but check your answer. How do you check your answer? FOIL. Use FOIL. See if it works out. If it works out, it has to be the answer. So everyone should do FOIL on that one, on what you thought the answer was, and hopefully you get it right. And if not, at least you know it. Okay, Abby, what'd you get?
I got n minus 4 times n minus 10.
Is that correct?
Yes.
You sure about that?
Yes.
I got something a little bit different. But mine is a little different. Oh. You checked it? Then we're good, right? That's it. I got m minus 10 times m minus 4. That's a little different. Okay, good job, Abby. How many of you got this? How many of you checked it and knew it? Abby should raise her hand because she knew it. Did Mr. A make you doubt a little bit, Abby? A little bit? Okay. I still got it in me to make people doubt. No, some of you already know when I try to make you doubt, it's to make you more firm on your answer. Like, I don't know. And then eventually you're like, yes, Mr. A, I know it. And then that's good because then you can do that on a quiz or test. Okay, I'm going to give you one more. And I'm going to give you, this one's for fun, and it's just to show you there are other types. But I'll give you 1 minute to work it out and do your best, okay? Number 31. And please don't call me for giving you this one, but do your best. You have 55 seconds left. $30 seconds left. Oh, don't worry, it's only 25 now.
You can't do that.
You have 20 seconds to figure it out. Hurry. 10 seconds.
I got part of it. I didn't get negative.
Oh, you got 5 seconds, don't worry. All right, put your pencils down. Who got it? Okay. Oh. All right, Carson. What'd you get, Carson?
I got t minus 7 and times t plus 5.
All right, it's minus 7 plus 5. All right, what's negative 7 times positive? Oh. Oh, but negative 7 plus 5 is negative 2, but that doesn't work for both of them. See? How about this? Listen carefully. I'm going to give you 30 seconds, and you can ask anybody around here. Go.
You're wrong, Jenna.
Jenna, close it. Close it, Jenna. There you go. 10 seconds.
It's an
Oh, there you go. So like 95% no solution. Okay, that's pretty good. Lucy, do you have it? You look like you have it already. Okay. All right. Stop talking. And, okay, here it is. Oh. Okay. It's prime. You call it a polynomial prime. That means it can't be factored anymore. And yes, nothing fits in those. So you can either leave it like that or you can write prime. So some of these, listen very carefully, some of them, and I'm talking like 1 or 2 maybe, are prime. And I would say don't just say they're all prime because that's not going to be the case. 1 or 2 will be prime, and it might not be that first one you think it is because you got to think about all the factors. So are all trinomials able to be factored? No. And that's okay. It happens. So that's a variety. You know what? Just because we do have a little bit of time, that's factoring trinomials with a coefficient of 1. So all of them had 1. I'm going to give you this next problem, and I want you guys to think about it. You can't, you can talk to each other. I'll let you guys kind of think it through. Let's go with number 16. Number 16 on page 578. Do you notice that one's different from the ones we looked at? So it's not the same process per se, but you can figure it out. So it is possible to figure out. And it's not prime, by the way. Please don't say it's prime. And it's just one more step up. It's not really that tough, but you do have to think about it just slightly. So that's number 16. 3d squared minus 12d plus 9. Oh, what a bad way to end it. Does anyone know what you're supposed to do here first?
You do 1d for 3d.
No, there's actually something you do before then. Before you even trying to get into binomials, there's something
You divide it 2 by 3.
Isn't there a GCF of? Now I can factor it out. All right, we'll talk more about that later. Sorry? That's all right. By a third, maybe.